Welcome to this puzzle session. We have the following puzzle. So 5 lattice points are chosen on an infinite square grid. Let me explain what that means. So just like we have the Cartesian plane R2, which has the points of this sort where A and B are real numbers, just like in high school we have this coordinate geometry in which we have ordered pairs of points. Each entry of that ordered pair is a real number, and then we write equations of lines, etc. So here what we have is we don't have all real numbers, we just have those ordered pairs a comma b where a and b are integers. A and b are integers. So just if you consider those ordered pairs, that is what we are calling a square grid, the infinite square grid. So it looks like this. You have these vertical lines and these horizontal lines. Somewhere you could say this is the origin, then this is 1 comma 1, this is 1 comma 0, and so on. So just collect only those ordered pairs where each entry is an integer, that is the infinite square grid, and 5 points are chosen on that infinite square grid. Every point of the infinite square grid is called a lattice point. So we have just chosen 5 points in that infinite square grid. What the problem asks us to prove is that the midpoint of 2 of those 5 points is also a lattice point. So perhaps we should see an example. What are we trying to say? So we have this infinite square grid. I hope you can see these white lines. And suppose we choose 5 points. So let's say this is 1 point, this is some other point, this is third, let's say maybe this is fourth, and this is the fifth one. So the midpoint of these two is not a lattice point. This is not a lattice point. These are the lattice points, but this guy is not a lattice point. Similarly, the midpoint of them is not a lattice point, not them either. Well, these two have that property. If you take the midpoint of these two, you get this guy, and this is a lattice point. So the problem says that whenever you pick 5 points, you will inevitably have this situation where you will be able to find 2 points whose midpoint is again a lattice point, meaning it again has both coordinates integers. So very interesting. So before we get to the main solution, let us look at some basics before we get there. So suppose I am given just 2 coordinates, meaning 2 points whose coordinates are x1, y1, x2, y2, and right now don't even assume that these are lattice points. These are just on the Cartesian plane. So x1 is a real number, y1 is a real number, and same for x2 and y2. So then the midpoint of these 2 points is given by this formula, and I'm sure this is familiar from high school coordinate geometry. Alright. So the midpoint is a lattice point, meaning both of its entries are integers if and only if this and that are both even integers, because it is only the even integers which when divided by 2 are integers. That's the definition of an even integer. So the midpoint of 2 points is a lattice point if and only if the summation of the first entries and the summation of the second entries are both even integers. Very simple. Okay. So therefore, if we are given 2 lattice points, x1, y1, x2, y2, meaning all of these are integers, then the midpoint is also a lattice point if and only if x1 and x2 have the same parity and y1 and y2 have the same parity. So what is this this word parity? So let me say a few words about that. So we say that x1 and x2, or just let's say any 2 integers, let's say m and n, are said to have the same parity, if they are both odd or both even. So parity of an integer is just the evenness or the oddness of the integer. That's it. So if two integers are both even, then we'll say that they have the same parity. If they are both odd, then also the same parity. If one is even, the other is odd, then they have the opposite parity. Okay, so so far there's nothing very interesting happening. We just made some simple observations, and now here is the main point. Given a lattice point, so a and b are both integers, we'll say that a comma b is of type e comma e if, or let me just say type EE, it's better that way perhaps, type E, or yeah, okay, let me just write E comma E. So we'll say that it is of type E comma E if A is even and B is even. So this capital E denotes even. So if both of the entries are even, then we'll say it's type E comma E, and similarly, if the first is even, the second is odd, then it's EO. If first is odd, second is even, then it's OE, and if both are odd, then it's OO. So we just record the parity of the integers in this data. Okay, so now what we are going to use is the pigeonhole principle. If you are not familiar with it, you can follow the video link that is flashing on the top right corner of the screen. And if you are familiar with it, well then you can just follow what I'm going to say. So what we have is 5 integers and 4 types. So not 5 integers, we have 5 points. So first point, second point, third point. Let me do away with this grid. So we have 5 points, some, I don't know how they are, some 5 points, and we have 4 types. Each point is one of these types, and exactly one of these types. So think of them as pigeons and think of them as cages. So we have 5 pigeons and 4 cages, and well, every pigeon goes to some cage. So by the pigeonhole principle, 2 of these pigeons should go to the same cage. But what does that mean? It means that 2 of the points have the exact same, there are 2 points here such that, let's say, just for concreteness, let's say both of these go here in this particular cage. Then the first entry of this and the first entry of that are both even, and the second entry of this and the second entry of that are both odd. So the first entries of these 2 points have the same parity, and the second entries also have the same parity, and therefore their midpoint is also a lattice point. So that finishes the proof. A very simple application of the pigeonhole principle. Not at all a hard puzzle, but maybe if you're seeing this kind of thing for the first time, it may seem a little bit non-trivial. I hope you enjoyed this puzzle session. As usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.